This episode is brought to you by Cisco Educational Premium. Did you know that Schrödinger equation is a partial differential equation? Schrödinger equation tells us everything we need to know about a quantum system. The Newton's equation F is equal to ma tells us everything we need to know about the macro world around us, while the Schrödinger equation tells us everything we need to know about the quantum micro world below. Schrödinger equation governs the wave function of a quantum mechanical system. It gives the evolution of a wave function which describes an isolated quantum mechanical system. Schrödinger equation was postulated in 1925. It was postulated by Erwin Schrödinger. Erwin used William Rowan's Hamilton analogy between mechanics and optics to formulate it, but it was only good for describing quantum mechanical system. He wasn't sure with its meaning. Quite pragmatic, such a stereotype scientist. He published it in 1926 and was awarded the 1933 Nobel Prize in Physics. Schrödinger equation is analogous to the classical energy equation. Energy equation we are talking about here is energy is equivalent to kinetic energy plus potential energy. Schrödinger equation is I reduce Planck's constant H partial on partial T, the pitchfork which is called psi bracket x comma t bracket is equivalent to square brackets negative reduce Planck's constant square on 2m partial square on partial x square plus capital V bracket x comma t bracket closing the square brackets psi bracket x comma t bracket. So we have this first part representing energy, referring to the classical energy equation. Second part representing kinetic energy, and the third section representing potential energy. In Schrödinger equation, psi bracket x comma t bracket is a wave function. This is what we call a complex wave function. M is the mass of our quantum particle. Vxt, on the other hand, is the potential that represents the environment in which the particle exists. Constant I is the imaginary unit, and H is the reduced Planck's constant. Schrödinger's equation is a linear differential equation. This means that if two state vectors psi1 and psi2 are solutions, so are the linear combination psi is equivalent to A psi1 plus B psi2 of the two, where A and B are complex numbers. It's worth noting that this mathematical possibility allows for physical property of superposition of quantum states. Schrödinger equation can be applied to hydrogen atom. Schrödinger equation will evolve to E psi is equal to negative H, which is reduced Planck's constant square, on 2 mu delta square psi minus q square on 4 pi epsilon naught r psi, where q is the electron charge, r is the position of the electron relative to the nucleus, r is equivalent to magnitude of r, or vector r is the magnitude of the relative position. Potential term is due to the Coulomb interaction. Epsilon naught is the permittivity of free space, and mu is equivalent to mq mp on mq plus mp, is the two-body reduced mass of the hydrogen nucleus of mass mp and electron mass mq